Okay, so we're going to talk about something called separation of variables. And I talked about it a little bit in a video that I put out last week, but we are going to go over it some more, and this is a little kind of puzzle type thing that you do. So essentially what you're going to do is you're going to solve for y. So they've given us this differential equation, and we're going to use separation of variables. So what's going to happen is we're going to get everything that involves y on one side. We'll really separate the two variables because it doesn't have to be y and t or x and y or whatever. So we're going to separate the variables to two different sides. So in this particular case, get dy and any y's on one side, dt and any t's on the other side. So for this first thing, to get dt over here, what it would really look like we're doing is multiplying both sides by dt. That's a good way to think of it, but that's not really kind of what's going on. So a guy named Leibniz, he came up with this situation here where if I have dy, that's the same thing as y prime dt. Well, in this particular case, so y prime is the same thing as dy dt. And so what we could do is we'd take 2t and we would plug it in right here. And what we're going to end up with is that dt moved over to this other side. So it's not really like we're multiplying both sides by dt, but the shorthand way of thinking of it is to do that. So we're going to move dt over here, and we're going to get 2t dt. And then what we want to do is we want to integrate each side independently. So when I integrate dy, I'm just going to get y. Now, I'm going to do this one time, but after this one time, we won't write it like this anymore. So we know that when we integrate, we always put plus c. So we have some c on this other side, and that's going to equal, and I'm going to integrate this side here. So that's going to be 2, and then I'm going to take t, I'm going to raise it a power, and then I'm going to divide that by that power. And then I'm going to add c. Now this is a different c, so we can call them c1 and c2 if we want. These 2's are going to cancel here. Now, we don't know what these constants are, and they're going to stay constants until we talk about particular solutions. And so what we know about algebra is I know that if I have some constant, so some number, if I wanted to move it over here and combine it with this other constant, I could do that. And so what's really going to happen is move that over here, combine the two constants together, and we're going to just call it t squared plus c. And c is just, I've combined those two constants, moved that over. So then what we would do is we would look for this in one of these other solutions. So if we're looking on this page, there isn't any. We're looking for something with a t squared, and then plus or minus some number. So that's going to be on the second page down at the bottom. So we have this t squared plus 8. So 8 could be the constant that we have here for c if we figured out the particular solution. So we're going to say that that is the next one that we're going to go to. So we're going to say that's number 2. And then we're going to solve that one. So we have dy dt equals 1/2. Okay, dy dt equals 1/2. So I want to separate these two things, so I'm going to move dt over here. And then I usually never move the constants. I usually just leave them wherever they are. So we're going to end up integrating. The integral of dy is going to be y. And I'm not going to put plus c because I know I'm going to end up moving it to the other side. So I'm just going to add the 1c on the other side. Integrate this over here. We're going to have 1/2 x and then plus c. Oh, not x, t, because we're talking about dt. So 1/2 t plus c. And that is our answer. So we'll look for that. We'll look for a 1/2 t plus or minus some number. So that's going to be back on this front side. So we're going to say this is going to be number 3. And we're just going to continue this pattern. So move our dt over here. So we're going to have dy equals 1/2 t dt. And integrate. Y equals 1/2 t squared over 2 plus c. So this is going to end up being 1/4 t squared plus c. So 1/4 is actually going to be up here. And it's a -2. Even though we put plus c, it's just some constant. It could be plus -2. Okay, so we're probably going to go through number 5, and then I'll have you guys do the rest. So move our dt. So we have dy equals t squared dt. Integrate. Y equals. And when we integrate this, raise it a power, divide by that number. So we have 1/3 t squared plus c. And that's all we need to do. All right, so this is going to be the last one. So this is front page here. So 1/3 t cubed minus 4. And this should have been a cubed. I put squared. I wrote 1/3, but I didn't change the power. All right, so this one says, sometimes you'll need to factor to help you separate. Okay, so we're looking at this one. dy dt, it gives you 2ty minus 8t. So to figure this one out, I would actually need to factor out the t. So we're looking at it like this. I want to get this dt over here, but I also want to get the y over here. So I'm going to multiply the dt over here. And like I said, not actually multiplying it, but that's the concept we need to think. And then I also need to think that I'm going to divide y minus 4 over here. So we'll have 1 over y minus 4 equals 2t dt. And we're going to integrate. And I forgot my dy. So when we integrate 1 over y minus 4, that is going to be the natural log of y minus 4. And that's going to equal, and we're going to have 2t squared over 2 plus c. So that's going to change to the natural log of y minus 4 equals t squared plus c. Now we're trying to solve for y. So if I'm going to solve for y, I got to figure out how to get rid of this natural log. So if I take e and I raise it to the natural log, those are going to cancel each other. So we can do e to the natural log of y minus 4 equals e to the t squared plus c. So those are going to cancel, and we're going to get the absolute value of y minus 4 equals e to the t squared plus c. I want to get rid of this absolute value, so to do that I'm going to put a plus or minus on this other side. And then I will add the 4 over. So I have 4 plus or minus e to the t squared plus c. Now, when we go around looking for a scenario where we have e to the t squared plus c, we're not going to find one, okay? And so what happens is when I have an e and it's raised to two things that are being added together like this, this, when I'm using my e rules, can be e to the t squared times e to the c. Well, when I take e and I raise it to a constant, it's still going to be a constant. So this can actually turn into c because it's still just some constant that we don't know. So we can rewrite this as c e to the t squared. So what you'll really end up looking for is c e to the t squared. And on the next page, there is a question right here that is 3e to the t squared plus 4. So this is going to be number 6. And I'm going to have you guys finish out the rest of that.